In this lesson, we are going to learn how to define the load patterns. In this example, the static loads acting on our building consist of the dead loads, the live loads, the earthquake loads, and the wind loads. So, to define them, go to Define menu, then select Load Patterns. So, here in this form, you can define any load pattern you want. And here, as you can see, two load cases are automatically defined. The first one is the self-weight of the building. So, the self-weight multiplier is taken by 1. And the second load is the live load, and its type is live. According to the ACI code, if your building is higher than 5 stories, you can change its type to reducible life. But in our case, I will leave it as live. And remember, only dead load can have self-weight multiplier equal to 1. This indicates that this load case will automatically include 1 times the self-weight of all members. Now I need to add a new load pattern for the walls and the floor covering. So, under the load, name it SD and select the type Super Dead. Then click Add New Load. As you can see, a new load pattern has been assigned with name SD, and the self-weight multiplier is equal to 0. Now, to start the seismic analysis of the building, we have to define the seismic load that is acting along the positive and in the negative directions, and also along the positive and the negative y directions. So first I am going to define the seismic load that is acting in the x direction. So under the load, name it EX1. And under the type, select seismic. In auto-lateral load, you can see several international codes of the earthquake analysis being listed here. So you can select any code according to your design. But here I will select UBC 97 code, as it's the international code and the most common used around the world. Now click Add New Load, so that you can see the seismic load in the x direction has been added. Next, we need to define the earthquake load parameters. For that, go to Modify Lateral Loads. So here, one thing to note is that you have to be aware about the factors and the coefficient used for calculating the time period and base shear, as they vary depending on each code. So here in the seismic load pattern, first let me start with the direction and the eccentricity. So here I am going to uncheck all of these boxes. Then I am going to select the x direction plus positive eccentricity. So here, give a value of 5% for the eccentricity. Now for the time period, I want ETABS to calculate it. So check the program calculated option and set the CT to 0.02. Now select the story range. So select the top and the bottom story. Here is the response reduction factor. And according to UBC 97, it will be 4.5. Now, here is the soil type and seismic zone factor. You can adjust them according to your code and the soil report. In our case, I am going to choose the SC for the soil type and the 0.2 for the zone factor. Finally, we have the important factor, which is one for residential buildings. Now click OK. So here we have defined the earthquake load along the x1 direction. With the same steps, I am going to assign the earthquake load in the x2 direction. So name it EX2 and choose the same previous parameters. Now go to Modify Lateral Loads and only select x direction with negative eccentricity. Now enter the previous parameters again. then click OK. So here you can see the EX1 and the EX2 are being assigned. Also, you could combine them in one load pattern, but I prefer to separate them. Now I'm going to assign the RC quick load in the Y direction. So name it EY1 and choose the same previous parameters. Now go to modify lateral loads, and here only select Y direction with positive eccentricity. Now enter the previous parameters again, then click OK. So here you can see the EY1 are being assigned. Now I'm going to add the EY2. So name it EY2. Now choose the previous parameters again, then click modify lateral loads, and here only select Y direction with negative eccentricity, then enter the previous parameters again, then click OK. Now I will define the wind loads in the X direction and in the Y direction. So name it W and its type wind, also according to UBC 97. Now click modify lateral loads. So here I will let these options by default. Now click on modify both. So here we can see that ETABS took the wind effect in direction 0 degree, which is the X direction, and 90 degree, which is the Y direction, so that I don't need to define another wind load pattern for the EY direction. But if the building was a non-uniform in plan, that means you have to add another angle to this text box. Now we need to enter the wind speed, but note that it's mile per hour, so I will take it 105 mile per hour. Here we have the exposure type B, C, D, and it's depending on the location of the building. I will take it B, and the important factor is also 1. Here choose only the floor above the earth level, so if you have a basement you don't need to choose it, as wind affects only on the floor above the ground level. Now click OK. Now go to define load cases. As you can see here, all load patterns have been defined automatically in load cases. However, if you change any of load pattern's name, you also have to change it manually in load cases. Now it's the end of our lesson. In the next lesson, we are going to learn how to define the mass source. So hang on for that.